Class, this is our last section of our last chapter. Hallelujah. And this is on Tuesday, April 21st, the Tuesday of our fourth week. And this is in 12.6, the law of cosines and the law of sines, page 608 in your textbook. Now look at our triangle over here. We have a triangle ABC with an altitude coming straight down from B, making a right angle with the base at D. And we have sides x and b minus x to the right and left of D. And we have the h and the two sides being C and A opposite their angles. So now we can say that c squared is equal to x squared plus h squared using the Pythagorean theorem in triangle ABD, the left triangle. But also a squared is equal quantity b minus x squared plus h squared in triangle BDC, the right triangle, right triangle. Now we're going to expand the b minus x squared and say that a squared is equal to b squared minus 2bx plus x squared plus the h squared that was there above. And now we can remember that x squared plus h squared is the same as c squared from the left right triangle. So we can substitute for that. A squared is equal to b squared minus 2bx plus c squared. Now seeing that cosine of A is x over c and multiplying both sides by c, x is equal to c cosine A. So now we can say that, substitute that in for x. So a squared is equal to b squared minus 2bc times c cosine A plus c squared. And now rearranging, a squared is equal to b squared plus c squared minus 2bc times cosine A. And notice that the cosine A at the end is the angle opposite the side A that we're trying to find, and that's what the line indicates. Excuse me. Now the law of cosines for any triangle ABC that's a non-right triangle, and this is how we find all three sides, the pattern's the same. So a squared equals the other two sides squared added together, b squared plus c squared, minus 2 times those sides, bc, times cosine A, the angle opposite our side we want. And b squared equals the two sides that are not wanted, a squared plus c squared minus 2ac times cosine B, the angle opposite our side we want. And c squared equals the other two sides squared, a squared plus b squared minus 2ab cosine C. Now, applying this, in example 1, we're going to find side A, opposite angle A, opposite 57 degrees. If a measure of A is 57 degrees, the side opposite angle B is 6, and the side opposite angle C is 9. So to find a squared, we say b squared plus c squared minus 2bc times the cosine of the angle opposite A, 57. So 6 squared plus 9 squared minus 2 times 6 times 9 times cosine 57 is equal to ANS, I'm calling answer, but the calculator will show something like 58.2. But to get the most accurate answer, we're going to say second x squared, which will give us the square root, and then second negative, which will put ANS, which is the ANS from the above line. So to be most accurate, we can say that A is equal to second x squared, second negative, and this is how I'd like you to do it, and this will give us 7.6 for our side A. Now for example 2, we're going to solve for the side unknown and the two angles that are unknown. So this is solved for the triangle. So first, we have side A given as 5, side B, opposite B angle given as 6, and the angle we want to find C is opposite 78 degrees. So c squared is equal to a squared plus b squared minus 2ab times cosine of that opposite angle, 78. And so 5 squared plus 6 squared minus 2 times 5 times 6 times cosine 78 is my 48.5 or ANS. And so I can do second x squared, second negative, to give me square root of ANS is 6.97. Now, in order to get the angle A, we had to get all three sides. That's why we had to get side C first. So now this formula, rearranging the side formula, is cosine A is the other two sides, b squared plus c squared minus a squared, the side opposite the angle we have that we're trying to get, over 2bc. And so we plug in as 6 squared plus 6.97 squared minus 5 squared, and we have to hit enter on that top line, and then we divide by parentheses, and a and s will come up before the divide. A and s divide parentheses 2 times 6 times 6.97, enter, and then we'll have an a and s, we'll have an answer. And whatever that answer is, we're going to go up above to the third line here in the corner, as a is equal to second cosine, second negative, giving us cosine inverse a and s, which is 44.6 right there. And so that's our angle A. And to find angle B, we just take 180 minus 78, which we were given, minus 44.6, which we found, giving us 57.4 for angle B. Now, when all sides of a triangle are known, the law of cosines can be rearranged like we just did to solve for the cosine of one of the angles. Now watch how I do it for one of them. So if I start out with a squared equals b squared plus c squared minus 2bc times cosine a, and I subtract a squared from both sides, and I also add 2bc cosine a, so in other words, I'm bringing a squared over to the right and 2bc cosine a over to the left, then I have 2bc cosine a is b squared plus c squared minus a squared. Now I divide both sides by 2bc, and now I've got it. Cosine A is equal to b squared plus c squared minus a squared over 2bc, like we just did on our previous example. And I can do this for the other angles. Cosine B is the other angle squared, other sides beside b squared, a squared plus c squared minus b squared opposite the angle B, hit enter, then divide parentheses 2 times a times c. And then of course we'd have to second cosine, second answer. Now cosine c again is a squared plus b squared minus c squared, enter over divide parentheses 2ab. They all have the same pattern. Now the law of sines differently can be applied when two angles of any side are known. So in other words, either AAS triangle or ASA triangle works for law of sines. This law can be derived by deriving each expression in the SAS side angle side area theorem by 1/2 ABC. So watch how we do this. So the area, which we did on the homework, for any triangle ABC, a non-right triangle, is we can take 1/2 BC sine A is equal to 1/2 AC sine B is equal to 1/2 AB sine C. And these are all triangle areas for given two sides and the angle between. So if we take each of those three and divide by 1/2 ABC, on the first one we divide by 1/2 and BC cancel, so we're left with sine A over A. And then on the second one, the 1/2 cancels and A and C cancel, so we're left with sine B over B. And on the third, the 1/2 cancels and the AB cancels, so we're left with sine C over C. So that's the basic form of the law of sines: sine A over side A, sine B over side B, and sine C over side C. Or if you want to solve for the side, you can reciprocal everything and do A over sine A equals B over sine B equals C over sine C. And now for example 3, we're given angle A is 53, B is 45, and side AB is 12, giving us an ASA triangle. Now we can quickly get the third angle, C, as 180 minus the two given angles, 53 minus 45 is 82. And we can set up the law of sines for sides as A over sine A equals C over sine C, or A, what we're trying to find first, over opposite angle sine 53 is equal to 12 over opposite angle sine 82. And when we multiply both sides by sine 53, we get A is 12 sine 53 over 87, or approximately 9.7. Now we can do that again for side B, as B over sine B equals C over sine C, and that gives us B over sine 45 is 12 over sine 82. Multiplying through by sine 45, we get B is 12 sine 45 over sine 82, and that's 8.6. Now example 4, this is a more involved example. The youth group hikes from their base camp for 3 miles southwest, 45 degrees south of west. And notice on my picture here, at point A, I'm going 45 degrees in the south direction from west or left, okay? And then hikes 4 miles, 60 degrees north of west, okay? So notice at the bottom where B hits, where the 3 ends, then I have 60 degrees up north from west, and that's a 4 miles, okay? So those are the directions. Describe their final location and in relation to their base camp. So angle B is 30 plus 45, you can see them indicated down there, or 75. So that allows us to find side B now, because we have A and C and the angle between them. So B squared is equal to 4 squared plus 3 squared minus 2 times 3 times 4 times cosine 75, or 16 plus 9 minus 16.2, or 18.8, and the square root of 18.8 is B, which is, where is it? 4.33, okay? Now we can get angle A, and we'll get angle A as B squared plus C squared minus the opposite side A squared over 2BC. And so we do B squared is 4.33 squared, which we just calculated, plus 3 squared minus 4 squared. Now we have to hit enter, and then we hit divide, and up will come ANS divide. Then we have to do parentheses, 2 times 4.33 times 3, enter, and we'll have an answer there, but it won't be our angle. We'll have to take second cosine, second negative, to get, or second cosine 0.4522 is 63 degrees for our angle A. So now we know that A is 63, the whole angle, minus 45, that direction we were given first. So that makes it 18 degrees. And now on the bottom, they are 4.33 miles B at 18 degrees north of west, going up from left of their base camp. Okay, now the homework starts on page 611, and we're going to have our generic triangle ABC with side A is 5, side B is 6, and angle B is 27. So we first have to get the sides. B squared equals A squared plus C squared minus 2AC cosine B, or 5 squared plus 6 squared minus 2 times 5 times 6 times cosine 27, or ANS of roughly 7.5, and our B is second x squared, second negative, or ANS, which comes to 2.7 approximately. Now for cosine C for the same triangle, for a different triangle, is A squared plus B squared minus C squared over 2AB, where we know that A is 11, B is 13, and C is 10. So 11 squared plus 13 squared minus 10 squared, enter, over divide, which will come up ANS divide, parentheses, 2 times 11 times 13, close parentheses, enter, which would be 0.6643, or the ANS that I'm calling out, would now C, angle C would be second cosine 0.6643, or second negative, either one, That would come out to 48.4. Now for 6, we want b squared equals a squared plus c squared minus 2ac cosine b, where a is 7, c is 5, and angle b is 40. So 7 squared plus 5 squared minus 2 times 7 times 5 times cosine 40 is 49 plus 25 minus 53.6 equals 20.4 roughly, and 20.4 square root is 4.5. Now I can get b using law of sines on 8 because I have 2 angles and a side, so that would be AAS on 8. I have a 6 side for C and a 9 for A and an angle for 71 for B. So that would be 2 angles. I have 52 for C. So I have 71 and 52 angles, and side C is 6. So I'll use the law of sines. B over sine 71 equals 6 over sine 52, cross multiplying. B is equal to 6 sine 71 over sine 52, approximately 7.2. Now for 10, I have A over sine 33 is 21 over sine 80. Cross multiplying A is 21 sine 33 over sine 80 is approximately 11.6. And angle C here is for 12, 180 minus 45 minus 60, or 75, we need the angle. So C over sine 75 is 7 over its opposite angle, sine 45, and C is 7 sine 75 over sine 45, or 9.6. Now they're asking which cases can be solved using law of cosines. Well, we can do a SAS because then we have 2 sides and an angle between. And also we can use SSS. If we have all the sides, we can get the angles. So those 2 for law of cosines. So now 16, we have an angle B of 48, an angle C of 79, and a side BC of 27. And that is an ASA, which uses law of sines. Now 18, these are easier. Angle A is 32, side B is 8, and side C is 3. So we have an SAS, side angle side, which works for law of cosines. Now on 20, we have angle A is 43, side A is 7, and side B is 9. Now we don't have an SAS, and we don't have 2 angles, so this is called the side-side angle, which is ambiguous, meaning it can have 2 solutions or 1 solution or none. We're not going to deal with those cases, but just to identify it. Now finishing up on 22, we have angle A is 24, angle C is 73, and side C is 12, so we have an AAS situation. And we can go for A over sine 24 is 12 over sine 73. Cross multiplying, we would get A equals 12 sine 24 over sine 73 is 5.1. Now for 24, again, we have 2 angles. Angle A is 28, angle B is 65, and side A is 16. We have an AAS. So now we can get the third angle always with 2 known. Angle C is 180 minus 28 minus 65 is 87. So we can set up for the law of sines. C over sine 87, the angle we found, is equal to 16 sine 28. Cross multiplying, C is equal to 16 sine 87 over sine 28 is 34. And now on the last one, angle A is 52, side C is 8, side B is 10, so we have an SAS, law of cosines. So to get A squared, we can say B squared plus C squared minus 2BC cosine A, which plugging in is 10 squared plus 8 squared, minus 2 times 10 times 8 times cosine 52, which is 100 plus 64 minus 98.5 equals 65.5, and the square root of 65.5 for side A is 8.09. Now that we have all three sides, we can get cosine B is a squared plus c squared minus b squared over 2ac. So we'll plug in now 8.09 squared, what we found, plus 8 squared minus 10 squared, hit enter, divide, ANS divide will come up, parentheses 2 times 8.09 times 8, and that will give us, enter an answer, and then we can say B is second cosine, second negative, and that will give us 76.8 degrees. Now to find our last angle C is 180 minus 52 minus 76.8, or what's left is 51.2, and that ends our 12-6, our chapter 12, and we're done now, except for the last test and the final. God bless you. Keep up the good work. I'm proud of you.